Greetings, Saintsmen. This is lesson 10.4 regarding inscribed angles and polygons. And first, what we need to do is describe what an inscribed angle is. So, make sure you have your compass readily available. Just create a circle. My software does it, but you're going to want to grab your compass, as always, for this chapter. Moreover, you need to make sure that you have your protractor as a straight edge. Okay, so, we have our center of our circle. Here's how we create an inscribed angle. So we're going to create a couple points on this circle, on the circle. So we have a center that I've marked, but I'm not going to give it a name because that's going to be irrelevant to what we're doing. What we were doing before is we would create, and you don't need to copy this part down because I'm going to erase it right away, but we connected the radii, right? So we took two radii, a point on the circle to the center. This is what we call the central angle. Okay, this is in your notes from the other day, all right? But we're not going to create that central angle anymore. Instead, what we're going to do is we have these points A, B, C, and
Please pardon the interruption. If anybody is interested in signing a card for your name of Delgado, ASP during break today, there's a card. Please stop by, sign your name, wish him well. We'll be this afternoon dropping off donations from the club and the Get Well card. So again, anybody interested in signing a card, stop by ASP during the break.
My apologies, I want this announcement that's in the background to end. There we go. And I'm not going to start restreaming the initial part of this instruction. So gentlemen, what we're going to have here is we have angle ABC. Now what we had before, like if we had B at the center, there's a central angle and we would refer to this arc AC and it would be congruent, correct? But that's not going to be the case when we have this angle that is called an inscribed angle. An inscribed angle, which means it's going to be formed by two chords which are going to share an endpoint as a vertex on the circle, all right? That will be, versus sharing the endpoint that's going to be at the center, right? We're going to be on the circle. It's going to be equal to 1/2 of the measure of arc AC. So this angle here, right, is going to be half of this arc here. So an inscribed angle is half the measure of the, and we'll call it the intercepting arc. So it's this arc that it opens up to on the circle. All right? Showing you guys something. Just food for thought. Let's take B, and let's move it up here. We're going to call this guy B prime. What would you surmise about A, B, C, and now A, B prime C? Believe it or not, these angles here, ABC and AB prime C, these two angles are congruent because they have to be. They're still an inscribed angle and they share the same intercepting arc. So no matter what, wherever it opens to, right, this angle back here is going to have the same angle measurement. Half of the arc. All right. So let's do big diagram. Oops. Draw a rather large circle on your paper. You're going to want to take up almost half a page, if not 3/4 of the page. All right. So, we have circle F. I'm going to create a number of points here. So I'm going to wind up, first I'm going to create my chords. Just time. Create your chords. So all these that are not quite look like intersections, I'm just going to kind of thicken up those points to make it look like it works. Okay. there. And right there. So, should have A, B, C, D, E, F is the center, and G. All right. So here's some angles for you. 1, 2, 3, 4, and 5. And what we have here as our givens is that we have circle F. Within circle F, the measure of arc AG is 20. Measure of arc BC is 40. Measure of arc GD is 108. And the measure of arc AG and CD, these don't look the same, but that's just because of my poor drawing. But these are going to be the congruent arcs here. Okay? So let's solve for all the numbers. Okay? So the measure of angle 1. How do we find it? Measure of angle 1. Take a moment and see if you could figure it out. Remember what the intercepting arc is for angle 1 all the way over here, right? That should give it away. So this guy is going to be equal to 10. AG is 20. Half of that, 10. So that's straightforward. Angle 2. Well, let's look at what the intercepting arc is. Do we know what BC is? Well, we do. We're given it as 40, so it has to be half, which is 20. So far, so good. Let's get angle 3. Angle 3 opens up. Its intersecting arc, right, is GD. Do we have that? Well, we do. It's 108, so this guy winds up being 54. Now we have angle 4. Yikes. Now, people will say, well, it's the same as BG, right? And that's not the case, because this is not an inscribed angle. We can do a central angle, right? That's going to go from here, right, at the center to points on the circle, or it's got to be on the circle where the vertex like 3 is, or 2 or 1, or even 5, which we'll get to, but 4 is not. But look at this, gentlemen. Look what we have here. That's a triangle, no? So you can just use another one of our problem-solving tools, the triangle interior angle sum, right? Because angle 2 plus angle 3 plus angle 4, that's all going to be equal to 180. All right? Angle 4, 2 and 3 is going to be 76. So what's left over? I'm sorry, 74. 20 plus 54 is 74. I'm not doing new math here. So angle 4 is 106. Angle 5. We'll take a look. Angle 5, its intercepting arc is also GD, just like which angle? But angle 3. So 3 and 5 have to be congruent, of course. They have the same intercepting arc, so it's going to be equal to 54. So, more fun facts / conclusions from what we just discussed, which is this. Inscribed angles of congruent arcs are also congruent, right? Like angles 3 and 5. All angles inscribed to the same arc are congruent, same deal. And if inscribed angles intersect a semicircle, guess what the angle measurement is going to be? Semicircle, the arc measures 180. So the inscribed angle would have to be a right angle. And where we have right angles, obviously even with the diameter now, we have a hypotenuse, we have a right triangle, and there's all sorts of fun things that we can now figure out. So, next up. right? We have circle P. TU. VS. And I got these little chords you gotta make sure that you connect. Like for example, VU is a chord, and so is US, which might be hard to see because it's so close to those arcs. I'm gonna call this angle 2. This is gonna be angle 1. Uh-oh. Okay, there we go. Goodness. That's scary. All right, so we have circle P. SU equal to UV. Angle 1 is equal to x plus 9. Angle 2 is equal to 2x plus 6. And find measure of angle UTS and measure of angle VUT. All right. Well, how do we get it? Well, how do we know what any of these things are? Right? We'll just take a look here. Gentlemen, here I have an inscribed angle. So this has to be congruent right here, or excuse me, it has to be a right angle. Moreover, so does this one. They both open up to the semicircle, right? To the diameter. Moreover, SU and UV are marked congruent. So gentlemen, what do I have here? Through hypotenuse leg, right? Because we have the reflexive side UT, the hypotenuse, I have two congruent triangles. Therefore, this and this are congruent, correct? 1 and whatever that angle is, which means 2 and this angle are congruent, right? Meaning that angle 1 plus angle 2 plus 90 is equal to 180. But then again, it's a right triangle, so 1 and 2, right? Because 1 and 2 are congruent. This would also be 1. So those two angles are the acute angles in a right triangle, and I have to be congruent. I'm sorry, gentlemen. I'm just distracted. Angles 1 and 2 are complementary, as they are the two acute angles in that right triangle. All right, and now we can actually substitute. Angle 1 is x plus 9 plus angle 2, which is 2x plus 6, is equal to 90. So then we saw 3x plus 15 is equal to 90. Minus 15, minus 15. 3x is equal to 90 minus 15, which is 75. So x is equal to 25. All right? That's not what we're asked for, though. We want to find UTS and UTV. So we need to take these things. UTS, right, which is the same as angle 1. We're going to take this 25, and we're going to plug it in for angle 1. Right? So angle 1 will equal 25 plus 9, which is 34, which is also equal to the measure of angle UTS. And then angle 2, two ways to do it. We could plug it in to 2x plus 6, right? 25. So 50 plus 6 is 56, or we can just take the complement to 34, which is also 56, 90 minus 34, which is angle VUT. Couple more things. Let me see here. Goodness, I'm missing my notes here. I gotta pull up on my computer. I want to take the notion of an inscribed polygon versus a circumscribed circle. So an inscribed polygon, so if I take my circle here, right, an inscribed polygon in is the key for inscribed. It's going to go into the circle. It's going to be a regular polygon. In this case, a regular quadrilateral, which is just a square. Okay. And of course, my square doesn't look like it fits. Just adjust it. Versus, if I take this triangle right here, right? And what I'm going to do is I'm going to circumscribe a circle. So it's going to be right like circumcenter, right, or a circumference. It's going to be a circle that's going to go about this, where all of those vertices are going to land on the circle. Yes, that is a little off-centered. So let me move this guy. Oops. Move my circle here. And adjust this guy so my vertices are on the circle. Okay? So when you guys see those terms, you understand what they are saying. Another one for you? Problem. Or actually another theorem, an inscribed quadrilateral will have opposite angles supplementary. Okay? So if I take quadrilateral, QRST, okay, and we're going to inscribed, and it's going to have it inscribed into circle M. Now we're going to talk about this with regard to Ptolemy at the end of the chapter, right? I'm trying to remember what he uses this word cyclic in his writing, or his, at least cyclic was the word that it was translated as. And we'll come up, take a look at his theorem with regard to these inscribed quadrilaterals with a circle. If we have the measure of angle Q, by the way, the guy I was just referencing is Ptolemy. You probably want to, just out of curiosity, if you want to look him up, because it'll come up on an activity we'll do at the end of the chapter. I'm going to find angle S and angle T. Now, we don't even have any sort of picture here, which is fine. No picture. But remember, opposite angles. So what's opposite in a quadrilateral? It's pretty straightforward. Remember, we're going to skip a letter. That's going to be my diagonal, Q to S. So supplementary to Q is going to be angle S. So angle S will be the supplement here for 87, which will be 93, right? 180 minus 87. And then here for angle R, right? Skip a letter. So angle T is going to be 78. That's it. It's that straightforward. Okay? Let me double check, make sure that I didn't give you guys the last example so you're not confused on anything that's going to come up in your notes. Double checking, triple checking. Nope, that's it. Gentlemen, good luck. And if you have any questions, reach out to me. See you in class.